Okay, this is Curry Caputo, and Curry's helped me out today. We're looking at my house in Hamden. And the first test he's doing involves using a blower door. Curry, can you give me just a brief overview of what you're trying to do right now?
Yeah, definitely. The blower door is used for a couple of things primarily. One is to depressurize the house. What we do is we create wintertime conditions in your house by closing all the exterior doors, locking all the exterior windows, making the house as tight as possible. Then we hook the blower door up in an exterior doorway and we depressurize the house, meaning we blow air out the fan, and as air is being blown out the fan, it is replaced by air through all of the cracks or gaps in the air barrier. The blower door is hooked up with some hoses to a digital pressure gauge. This digital pressure gauge tells us how much air is flowing through the fan at the imposed depressurization level. So what we're trying to do is to depressurize the house to a negative 50 pascals, which is roughly equivalent to a 25-mile-per-hour wind hitting all surfaces of your house at the same time. It will give me a reading in cubic feet per minute. A cubic foot is roughly the size of a basketball. And then what I do, depending upon the height of the house, its shielding, is I take the CFM 50 number, which is our depressurization number, and using some calculations, I determine how you compare to energy efficiency guidelines. What is the airflow under natural conditions through the house? And then, we're shooting for 0.35 air changes per hour is a building tightness limit that we try to reach. At that limit, you're not wasting heat through exhausting it out air breaches, and you're also maintaining indoor air quality. As we get below that 0.35 air changes per hour, or roughly the air in your house changing once every 3 hours, then we don't like to say too tight, we like to say underventilated. Okay. So we need to talk about coming up with some additional ventilation to maintain indoor air quality while still retaining the energy efficiency. So that's the first major component of the blower door, is that it allows us that diagnostic reading. The second important way that we use the blower door is with the thermal imaging scan. I have a thermal imaging scanner that detects surface temperatures only. It's not like an x-ray. I can't see through a wall, but I can see the temperature of an exterior surface. So as this blower door is depressurizing the house, blowing air out, air is being replaced through all of the cracks or breaches in your air barrier. That shows up in a color rendered picture of hot and cold, basically. So we get to see on this cold day, cold air being pulled in and striking those exterior surfaces immediately changes temperature. The infrared camera shows that very accurately. We can not only find out where the obvious air breaches are, but where the hidden air communication pathways are. A lot of people don't expect, an interior partition inside their house to be leaking out the door casing or out an outlet or a switch plate, but those pathways exist in your home. So the infrared doubled with the blower door allows us a very quick and accurate diagnostic procedure to find out exactly where all of the air breaches are in your building envelope.
Okay, so tell me first off, on the blower door, what have we seen so far here?
Well, we've seen that your house is relatively tight. Until I crunch the numbers, I can't tell you your comparison to the air changes per hour. But given the size of your home, the air changes are not incredible. You aren't wasting a lot of heat through air exhausting it. So you have roughly 2,800 cubic feet a minute at that 50 pascals passing through this fan. And what I will do is make some calculations, tell what that will be under natural conditions. Now, what we will find out, and what we have found out, is where all of those air breaches are. And it's you have a fairly tight building envelope. Okay. It is due to a polyethylene vapor barrier on your exterior surfaces. Whoever built the house had the forethought to actually get a really good air barrier in all these exterior surfaces, because any insulation type, whether it's foam or whether it's cellulose or whether it's fiberglass, depends upon a dead air space to create whenever you have airflow around through bypassing any of these insulation materials, it immediately degrades the R value of that material. So without a good air barrier against that fiberglass, it would allow air to pass through it, and your fiberglass would turn from insulation into air filter.
Okay, well, let's do this. What we'll do is we'll come back and take some more clips looking at where we had some cold spots in the house.
Excellent.